we need to find the general solution of this differential equation. So in this differential equation, I know that partial derivative of z with respect to x is small p and partial derivative of z with respect to y is small q, right? So writing this equation as x square into p plus y square into q equals to x plus y into z. And now writing the auxiliary equations or the Lagrange subsidiary equations. The Lagrange subsidiary equations are dx divided by the coefficient of small p, that is x square, equals to dy divided by the coefficient of q, that is y square, equals to dz divided by the right hand side, that is x plus y into z. And now we need to get the two independent solutions. For that, let's take these two ratios and integrating these two. Let me mark these equations as 1, and from first two ratios I am getting dx divided by x square equal to dy divided by y square, or dx divided by x square minus dy divided by y square equals to 0. And on integrating we get the integration of dx by x square minus the integration of dy by y square equals to the integration of 0 is a constant, and let me take that constant to be c1. Integrating the integrand 1 divided by x square with respect to x, that is 1 divided by x, minus integrating the integrand with respect to y, I will be getting 1 divided by y, yes, equals to c1. Y minus x divided by xy equal to c1, or it can be written as x minus y divided by xy equals to c1 dash, where c1 dash is a constant, that is equal to minus c1, right? I am taking minus c1 to be c1 dash. So this is the first solution I am getting over here. And now finding another solution, let's get back to our equations. If I use the multiplier 1, minus 1 and 0 and adding all these together, that means this is dx minus dy plus 0 divided by, when multiplying the denominator with 1 I get x square, when multiplying denominator with minus 1 I get minus y square, and multiplying the denominator with 0 I get 0 over here. You can either equate this to 0 or you can also equate this to any of these ratios. So I am preferring the last one. I am equating this to dz divided by x plus y into z, because I know that what is x square minus y square? It is x minus y into x plus y. So that I can cancel this one to this, and we can now integrate this very easily, right? So let's do this. So using the multipliers, (1, -1, 0), we get dx minus dy divided by x square minus y square equal to dz divided by x plus y into z. So this can further be written as dx minus dy divided by x minus y into x plus y equals to dz divided by x plus y into z, cancelling x plus y from both the denominators, and we get dx minus dy divided by x minus y equals to dz divided by z. And let's integrate both the sides. The numerator can be written as derivative of x minus y. I can write this like this. So it is the integration of derivative of x minus y divided by equals to the integration of 1 by z dz. So integration for this is log of x minus y equals to log of z plus the constant log of, let's say, c2. So this is x minus y equals to z into c2, or we can get x minus y divided by z equal to c2. So this is another solution from the auxiliary equations. So this is your second solution and this is your first one. Let's merge the value of the second solution to this first one, as c1 dash is x minus y divided by xy. I can use the value of x minus y from this c2. X minus y is z into c2. So it is z into c2 divided by xy. Taking this c2 in the denominator of c1 dash, I will be getting c1 dash divided by c2 equal to z divided by xy. You can also consider this to be another constant, that is c3. But before that, I am first taking the reciprocal for this. It looks good, xy divided by z. And now considering this constant to be c3. So I am getting c3 to be equal to xy divided by z. So another format of the solution, that is xy by z. So now writing the general solution. So it is f c1 dash c3 equals to 0, or so that is f of c1 dash is x minus y divided by xy, and c3 is xy divided by z equals to 0. You can also write the solution as f of c1 dash and simply c2 equal to 0. Here I have just changed the format of the solution. You can also write the solution as it is. That is f of x minus y divided by xy and c2 x minus y by z equals to 0. So you can write the solution both of the ways, where f is your arbitrary function. Okay, thank you. Stay blessed.